Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Legacy CDPs charge you a premium to keep your data in a black box. RudderStack builds your CDP on top of your data warehouse, giving you a more secure and cost-effective solution. Plus, it gives you more technical controls, so you can fully unlock the power of your customer data. Visit dataengineeringpodcast.com/RudderStack today to take control of your customer data. Your host is Tobias Macy, and today I'm interviewing David Yaffe and Johnny Graettinger about using streaming data to build a real-time data lake and how Estuary gives you a single path to integrating and transforming your various sources. So, David, can you start by introducing yourself?
Yeah, sure. I'm Dave Yaffe, co-founder of Estuary. I'm more on the business side. So myself and Johnny have been working together on various different projects for a number of years and different companies. We were formerly in the marketing space, built some technology that got us where we are now. And, we've been working together now for about 15 years.
And Johnny, how about yourself?
Sure. Hey, I'm Johnny. I'm the CTO of Estuary. As Dave mentioned, we've been working together for quite a while. I'd say, in many respects, I'm kind of like a real-time data plumber. I'm just deeply invested and steeped in like the intricacies of moving data at scale and quickly, and just have been spending a lot of my time there for about a decade or more at this point.
And going back to you, David, do you remember how you first got started working in data?
Yeah. So the last industry that I was in was marketing, and before that, advertising. So we had built a company called Invite Media a long time ago, and that was it was a real-time bidding platform. And so in that space, the goal is to listen to all of the potential requests for data for ads on the web, and then to respond to them. That's a very highly intensive data problem. You have to know exactly like what you want to show, where, and really that space just like set the framework for us getting into the real time space. We did that through a number of other companies. So after that, we built a company called Arbor. Arbor was a data platform, and that kind of led to the next step in our evolution towards where we are now.
And Johnny, do you remember how you first got started working in data?
Yeah, I had a brief stint in natural language processing, which is even at that time, and this was over a decade ago, it was a very data intensive domain. Looks very different from where we are now, just with deep learning and the advent of deep learning. But since then, as Dave mentioned, in the advertising technology space, there's just data everywhere. You have to move a lot of data very quickly in order to succeed in that business. So it was either sink or swim a little bit, and it essentially required just getting really into it.
So digging now into Estuary, can you give a bit of an overview about what it is and some of the story behind how it came to be and why you decided that this was the problem that you wanted to spend your time and energy on?
Sure. So I can probably start off, and I'm sure Johnny will add a bunch of light to what I say. But at a very high level, the last company that we built was a data platform. It helped advertisers and publishers share their data assets with each other. And for that, it was in the marketing space. The marketing space turns out that you really care about low latency data. When someone's on a website, they express interest in a product, they want that product for the next maybe 10 or 15 minutes before they go and buy it. So if you get in front of them very quickly, you might have an opportunity to influence their purchasing behavior. Because of that, we ended up valuing real-time data very highly for the last company. Marketing is an interesting problem too, because you care about the history, you also care about what's happening right now. So we wanted to solve that problem well, and we ended up building a streaming platform for that called Gazette. Johnny built it for real. So the reason that he built it, he can kind of get into those details, but I'll leave that there and have him kind of fill in the gaps.
We built Gazette for the last business, and honestly, the core reason for building it at the time, this was like 2013, 2014, we needed a lot more flexibility in terms of how we were moving data and being able to experiment and try things. And the main problem that Gazette solved and continues to solve is being able to work with sort of whole collections of data rather than buffers of data. We needed to be able to take a data set, kind of transform it in a different way, push it out to a different buy-side partner, and we needed to be able to do that at scale and also really quickly. So once we decide that we want to transform and push data into a place, we need to be able to backfill over months, potentially more of history, and also kind of stream from there in an ongoing fashion. And we needed to be able to do this without putting our production infrastructure at risk, because we're moving a ton of data through the system. And also, we were a startup at the time. We needed it to be something that we could do quickly and easily. That was the genesis and the core sort of motivation for Gazette for that business, and we kind of been building on it ever since.
And so the streaming ecosystem in general has been in development and in some measure of active use for on the order of a decade plus. Some of the kind of notable early entrants were things like Samza, Flink is one of the current favorites, Spark, Storm, I think, was one of them. There are a number of them kind of like faded from recent memory. I could probably dig them up if I wanted to, but in the early days of streaming, it was very much you can do it, but only if you have a lot of engineers to throw at the problem, because it was kind of a new area, a lot of still undefined problems in terms of the distributed systems capabilities. What are some of the edge cases that we need to discover? I'm wondering if you can talk about what you see as the current state of that streaming ecosystem as it stands today, and some of the lessons that we've been able to carry forward from some of those early experiments.
Yeah, in many ways, it looks a little bit like a snapshot of where it was 10 years ago. In a lot of respects, it hasn't really moved that much, especially in comparison to sort of integrations of technologies like the modern data stack. I think there are a few things that are missing still. One is sort of streaming is, the streaming ecosystem is oriented around buffers. You have buffers of data. Your Kinesis topic has a buffer of data that's 24 hours. Kafka, when you stand it up, it's still giving you 7 days of buffer. And yes, you can do segment offload, but there are some downsides of doing that as well. So these systems are basically oriented to think in terms of very recent data and not sort of the history of a data set. You like being able to think in terms of an entire collection of data that is continuously evolving, but where you need to go visit all that history from time to time. So that's one big piece, is just being able to think in terms of collections over buffers. Another is that state is still really hard. If you want to do some kind of stateful transformation, you can do it with Kafka streams, formerly Samza. You can do it with Flink and Spark and so on. But these frameworks really require that you adjust your thinking to the way that they model state. So if you want to work with a stateful streaming application, you basically need to design your application from the ground up to work with Flink's checkpointing mechanism, for example. And that's not really practical. Basically it's at a place where some organizations use it for really, really crucial operational use cases, but it's never going to be something you pick up for the third most important priority in your organization. Another challenge is that streaming is still very sort of event by event. Like if you're writing a streaming application, you're picking up one event, processing it, and moving it along. But that doesn't really work with a lot of tools that you might want to integrate with particularly well. Like, for example, how do you take a torrent of data and then maintain a view of that data in a Google Sheet, for example, where you can only update that sheet once a second? You're not going to be successful moving an event at a time into that Google Sheet or updating it based on one event at a time. And then finally, there's something that I think of as the tyranny of partitioning, which is if you have like a Kafka topic, for example, you have to choose a partitioning of that topic. And that partitioning is a super important knob, because once you start writing data into that topic, you're generally sort of mapping your data based on like hashing and doing modular arithmetic over some kind of routing key within your topic. And once you've arranged it into these partitions, it becomes a little bit set in stone, and it becomes very difficult to scale. If you realize that you got that partitioning wrong or you need to scale up, you're basically having to kind of take down or pause entire workflows and bring up replacements. So that can be quite awkward, and it's something that the modern data stack has solved really well.
And one other thing to add to that, change data capture is actually a place that streaming shines, right? If you're extracting data from a database, you want to do it at the log level. You want to do it at an individual row level, because that's just going to be a much more efficient way of interacting with the database. So I think that's a positive place on streaming.
Yeah, change data capture is definitely the thing that comes up most frequently in conjunction with the idea of streaming, and the kind of main entry point that most folks are going to grab for it. And so in terms of the overall ecosystem and what you're building at Estuary, I'm curious if there were any kind of core pain points that you were experiencing that pushed you into building a whole new streaming engine, because that's definitely not the kind of first answer to, hey, this thing doesn't quite do what I want. And I'm wondering kind of what were some of the fundamental architectural issues with some of the existing systems that prevented you from being able to just do an evolution from the current state of one of those platforms to saying, no, I actually need to do a ground up redesign, rewrite for being able to achieve the specific kind of optimizations and capabilities that you wanted to focus on?
I'll point at one place to kind of answer this question, and it's casting back to like why create a streaming system, why create Gazette, and this is again 2014. Kafka was on the scene at that time. Why create a whole other streaming system? There's one architectural capability that is pretty core to Gazette and still is core to what we do. So what Gazette does is it's basically representing sort of a streaming log of of your data in a sort of an append-only log. What it does is it's really just dealing with the really recent data that's being written to that log, and then pretty much as soon as possible, it's writing chunks of like historical log into cloud storage as regular files. So you get like regular files of JSON in cloud storage for all the historical data, and then just the really recent stuff is managed by this replicated broker configuration. And one of the key capabilities that enables is when you need to go reread a topic of data from Gazette, what you are actually doing is you are just asking the broker, hey, where do I go find the next gigabyte of data in cloud storage? And then you're going and you're reading it directly from cloud storage. And this is a huge architectural advantage because it allows for the brokers just to focus on the really near real-time stuff, what's happening right now. And if you have really large-scale consumers of data, they are able to just go fetch as much data as they can from cloud storage, which is a highly elastic resource in terms of IO operations. So it's really it's like crucial from an architectural perspective that you're able to get that kind of scale when consuming historical streams. And that's to this date, Kafka still, if you're trying to read a ton of historical data out of a topic, you've got to go through the brokers to do it. And that's an operational and scaling concern.
And I've definitely seen this kind of spill to disk, if you will, of being able to, when you get to the point of, I can't keep all of these events in memory or on local disk, I need to, page that out into cloud storage. And when you mentioned saying, okay, when I need to replay everything through the broker, I'm wondering what you see as the trade-off of saying, when I do kind of page that out to cloud storage, do you do that in a fashion where it's in Parquet files or something that it can be accessed via something like a Trino? Or is it something where we want to actually page that out in a format that is optimized for the broker because we want the broker to be the single point of access for working with this data, versus we actually want to age data out of the real-time stream into a batch-oriented mode where if you want to do aggregate analysis on this, you just use a different query engine kind of a situation?
Yeah, in truth, you can have both. So quite literally, a collection of data in Gazette and Flow as well is if you're writing JSON documents into that collection, you get files of your JSON documents in cloud storage, laid out in sort of a nice Hive metadata layout. So the true answer is you really can have both. JSON ends up being kind of a nice format for stream-oriented processing anyway. The Parquet, for example, is a great format for analysis, but if you are needing to read individual, like row by row in a streaming fashion, and you're doing some kind of data shuffle, the columnar representation of a Parquet file is not helping you, it's actually hindering you. So there are only a couple of formats that really make sense for true streaming reads of data, and that's JSON, Avro, a couple others.
I was just going to ask about Avro, so you beat me to it.
Yeah. Yep. The other factor on this is that if you've got a layout of files of JSON, you can plug that right into BigQuery as an external table, for example. So interoperability is a design goal from the get-go.
Absolutely. But going back to the question of batch versus streaming, where everybody has their own opinionated viewpoints about it. Sometimes people just have no opinion. They just do whatever comes easiest. There's definitely been a lot of investment in optimizing for the batch-oriented workflow with tools like Fivetran, Airbyte, and then obviously the cloud data warehouses, the Snowflakes, BigQueries, Redshifts of the world. I'm wondering what you see as the default mode that most organizations today would fall into when they say, I need to be able to do a bunch of stuff with data. Do they go straight into streaming land of streaming actually solves all of their problems, makes everything easier, or is it still easier to just use these batch oriented tools because that's where the ecosystem has invested all of the time and integration energy?
That's actually a question that falls right into our wheelhouse, right? Our goal is to make streaming as easy as batch, right? And that requires a couple of things. That it requires being able to have historical data and not just real-time data, being able to look at the world in terms of collections, so you get all of your data, including incremental updates, and also being able to take the paradigms that someone like a Fivetran presents and be able to present them in a streaming space. So that's really what our platform has tried to do. We have three legs to it. One is captures. Captures is you're taking data from external systems using configuration. The second is transformations. So it's not exactly a Fivetran where you're doing ELT as the only mode. You can actually do ETL or ELT. And ETL, it turns out has some good benefits in the real world, where you don't want to necessarily join all your data in the warehouse every single time. So sometimes it's good to do stuff like that before pushing it into the warehouse. And then the third leg is materializations, or pushing data into destination systems. One of the things that batch systems really focused on was data warehouses, right? Like that's what the Fivetrans of the world are focused on. And that's something you can do in a streaming fashion if you do some sort of batching. You actually have to batch, since most of these warehouses don't take every single event update. But you can also work with other types of systems. So think of NoSQL stores. You could work with search indexes or vector DBs. A lot of different applications can come out of this, which you really couldn't do in the batch space.
I would also, just taking a step back and looking at the ecosystem, there's very much a gray line between batch and streaming. If you look at what companies are doing with, Fivetran, for example, it is streaming most of the time. You're doing sort of an incremental, like just moving new data from one place into another. That is a stream. So I would, if you're making an architectural choice here, I would point out you can always go from a stream to a batch, but you can't go the other way. So if you have to pick one, what does that mean? And especially given that you pretty much want streaming anyway, given the benefits of incremental processing and cost reduction.
Yeah, it seems like streaming ingest as a thing is something that enterprises are really starting to latch onto. They're saying that they want a new reference architecture which loads their systems using stream processing. That is probably limited for the most part to big enterprises at this point, but I think we're starting to see it trickle down a little bit.
And in particular, for that kind of initial evaluation, the proofs of concept for a team that is building out a new capability or starting from scratch, what are some of the potential roadblocks or stumbling points that they're going to hit in the process of saying we actually want to go with streaming? What are some of the problems that they have typically run up against that then pushed them into the batch paradigm, and some of the ways that you're trying to address those shortcomings in the work that you're doing at Estuary?
Yeah, I'll start with, let's talk about CDC for a moment. A challenge that often comes up with CDC, especially when you get into really large databases, is the difficulty of backfills. So that's been a challenge in the space for quite a while. Debezium is a great tool, but if you hook it up to a 2 terabyte or more database, one challenge it has is that it essentially, like, your database is going to fill up its write-ahead log. It's going to fill up the disk with write-ahead log segments while your backfill is running. So one point difficulty is the challenge of doing CDC from larger databases. That's something we've seen several times now, and it's something we've invested a lot in kind of addressing and fixing.
That one isn't going to make you go into the batch space, because there's no better solution in the batch space, unfortunately.
Yeah, that's true, unless you're doing a full refresh of your table every time, which is, lots of money. So other challenges tend to be sort of transformation. Around transformation, you almost always want some kind of transformation of your data. As Dave mentioned, ELT is great, but I kind of think we're like the pendulum is swinging back a little bit towards like ETLT, which is really kind of just saying like transform it where it makes sense. Transform it while it's in flight if that works and helps you reduce cost or achieve the outcome you want. Transform it in the warehouse if that's easiest and works for what you need. So it's really about flexibility and being able to transform where you want. But in practice, when organizations have deployed streaming, transformation has been challenging enough that very often they just end up like streaming everything into a data lake right away and then doing transformation there. And at that point, you've already kind of given up the potential benefit of streaming in the first place.
Another thing is just trying to use streaming for the wrong workloads. Streaming is very good for data pipelining, for reshaping your data and putting into a batch system, actually. So you can do queries within a batch system potentially. So I think a lot of the time you'll see a big workload where they're trying to take everything and just put it into a stream processing space, where that's probably not the right way. Starting small, like any big engineering project, is probably the right way to go, and starting maybe with one critical workload and then expanding from there.
And one of the things that I'm particularly interested in as far as the paradigm mapping between batch or streaming is that for these batch workflows, there's been a lot of time and energy invested into these data orchestration utilities. So the Airflows, Dagsters, Prefects of the world. And I'm curious how that manifests in the streaming flow where you are doing these transformations. Maybe you need to be able to do a data enrichment in flight of that transformation where you're either joining across streams or you're pulling in data from an API as part of that transformation or querying a table to be able to pull in some additional context and managing the kind of dependency flows of data as it traverses one or multiple streams into and out of different batch systems. I'm just curious kind of what the data orchestration landscape looks like and its relative level of support for streaming, and maybe any kind of custom solutions that you've had to build up to support that, kind of bridging those paradigms with Estuary.
Generally, it's sort of very application oriented, which has made it very hard to sort of corral a comprehensive picture within the ecosystem of what your streaming data flow is. So by application oriented, I mean that you're writing a streaming application that's going, that is choosing the topics that it's going to read from at application runtime, and it is choosing the topics that it's going to write to at application runtime, which means that application really understands sort of the provenance of data and like what it's doing. But if you are outside of that application looking in, it becomes really hard to understand like what is this application reading, and for some topic that it's writing to, how did this data come to be? What exactly produced this data into this particular topic? So that deficiency of sort of understanding like the data flow and provenance tracking of data is something we've thought a lot about, and kind of it factored quite a bit into our design for how we model transformations within the tool, where the transformation is instead sort of declaring the sources of data that it reads and the transformations that are being applied to that data, but a transformation is one and the same with a collection of data. So essentially in Flow, like you build a collection of data, which is built through transformations of other collections of data. And one thing that allows for is a really tight understanding of provenance and exactly how that data product came to be, which is, crucial.
Yeah, the question of lineage is also interesting, where, as you said, because you have all of the streams, you know what those data flows are, but I'm curious if there are any interesting edge cases that you've had to manage as you move from the stream flow into the warehouse through some DBT transformations into a high touch or something, and kind of just being able to understand from a metadata perspective how to represent those different transition points as you move between these different paradigms and use cases.
Yeah, I'm not going to pretend that we've entirely figured this out, but the golden rule, I think, is really just consistency in naming, consistency in, essentially essentially representing that this is the same collection materialized into multiple views in different places, which is really kind of how people think about it. You're not thinking about like, this is my user's data set from my Postgres database or my MySQL database or in Snowflake. You're thinking like, this is just my users table, my collection of users, and it happens to be in one of these three places, but it is the same data. So encouraging fluidity and sort of understanding that it's the same data product and it's just being synchronized between these places is part of the answer here.
And another element of this space is the rise of data lakes and data lake houses as the place where you do these different batch transformations, particularly with the rise of different modern table formats. And I'm curious what you have seen as the impact of that evolution in the ecosystem and the viability and appetite for streaming as a data ingestion mechanism and some of the ways that those are playing off of each other.
I think in some respects, the rise of modern table formats it's organizations kind of wanting to own their destiny a little bit, just in terms of they have an enormous amount of data in these warehouses. The way in which that data is represented has huge implications on their cost to serve. And being able to sort of self-host and own that is appealing to a lot of organizations quite reasonably. So in some respects, I see it as kind of just a progression of, we've had BigQuery, we've had Snowflake on the landscape for a little while, Databricks as well. These are sort of an evolution, and a lot of companies are going to want to in-house this, and that's great. I would kind of lump them a little bit together categorically as a bit of the same thing, and you just have more choice now in the ecosystem of whether this is going to be something that you're going to self-host or whether you're going to use a vendor to manage your warehouse. But it's fundamentally the same techniques and the same architectures.
And digging now into the specific implementation of what you're building at Estuary and with the Flow platform, curious if you can start by just describing some of the system architecture around that and the different optimizations that you're focused on in terms of the use cases that you're supporting.
Sure. So some of the big architectural points are, number one, sort of thinking in terms of entire collections of data that are principally living in the customer's cloud storage, the user's cloud storage, that the streaming, we call it a real-time data lake, and we mean that quite literally, where it's literally a data lake of files in the user's cloud storage that also has a millisecond latency streaming component on top of it. So that's one key architectural capability. And when we talk about a collection of data, we're talking about this hybrid, real-time data lake that's actually enabling the storage of that collection. One of the other big architectural investments that we've made is really kind of bringing the MapReduce paradigm, not MapReduce is in the Java implementation, but just the paradigm of map and reduce into the streaming ecosystem, building it into the tool as a really first-class concern, making data reduction something that just happens all the time. So data shuffles and data reductions are just kind of built in and always there for you. And that's been honestly a very challenging engineering task, because when you talk about a data reduction for moving data into a NoSQL, like a Redis cache, for example, that's very fast. You don't need a lot of data around for a data reduction you might be doing. But we have users who are managing materializations into Snowflake, where we're needing to sort of roll up like tens of gigabytes of data every transaction, and essentially do reductions all over everything that's about to go into that warehouse. So enabling that scaling has been a challenge. And then final piece is probably connectors. Part of the sort of philosophy of what we've built is we really want to get out of the user's way in terms of the user being able to articulate, connectors for different systems they want to capture from or push data to, and even connectors that are performing transformation. So transformation in our platform is also a connector. And we very much have a goal of just being able to bring your own transformations over time in your own arbitrary languages.
Yeah, the only thing that I would add to that is change data capture. That's a pretty important concept, and when you get into very high scale use cases, and there are some implications of the way that you do it. So for us, that was something that we focused on up front and made sure that we were building our own framework, which is kind of based on the Netflix DB log implementation, to be able to do that very efficiently for both big backfills and instant transition over to reading the write-ahead log, actually doing both of those things at the same time, so you never have issues with that transition.
Another interesting consideration in this streaming versus batch paradigm and the data lineage question is the way that you think about data modeling, where in a streaming system, with CDC, obviously you're dealing with tabular structures, but if you're pulling in event-based data, then it's largely going to be denormalized and probably nested and have different kind of variability as you evolve the event tracking system. And I'm curious how you think about the data modeling question in a streaming flow and the managing those transformations and some of the ways that the downstream consumption factors into the considerations of how you think about the initial data structures that are entering into your streaming workflow.
Yeah, that's a great question. So we've built around the JSON object model. So there is sorry, let me start this answer over again. Yeah, that's a great question. We've built around the JSON object model, just as you said, if you want to deal with sort of event-based data, denormalized data, it's a little bit table stakes that you'd be able to represent truly deeply nested data, potentially even sort of documents modeling graph structures. So we built around the JSON object model, and we lean heavily on JSON schema, actually. So JSON schema, which is a standard, it's part of the Open API specification. It's essentially a lightweight language for describing how documents should be validated, and for representing like the structure and even some of the semantics of your documents. So when we talk about a collection of data and flow, that's a collection of JSON documents with a JSON schema, which is validated every time a document is touched within a collection, whether it's read or written. So naturally, that leads to some interesting questions about how do you map that to sort of tabular systems like databases, where they're thinking in terms of columns. And part of the answer here is what we call projections. It's essentially being able to define locations within a document and fields that name them. So when you materialize into Snowflake, for example, there's a bit of a negotiation that's happening between Snowflake and the Flow platform to figure out, okay, what are the locations that we're going to project into fields, into columns within that table. Most of that is automated, but basically the user is sort of empowered to fine-tune exactly what it is that's going to be mapped into columns and how.
Yeah, so to expand on that a little bit, if there's a specific type of data structure that isn't well met by the destination system, the user can decide how they want to map that in, if they want to do something to make it appear as just a raw JSON document, or something like that.
And so for teams who are interested in integrating Estuary into their data platform and into their data flows, can you talk through what that onboarding and integration path looks like and some of the ways that they should be thinking about the data modeling, system design, workflow management as they go from idea to initial proof of concept into larger scale production use cases?
At a very high level, we target working with as a SaaS platform at this point. So, getting started is pretty straightforward. You can essentially just log into it, configure your captures, get data into the system, and start working with it directly. It's designed to be a system that you can work with different personas. So you can work with, for instance, if you have a DevOps person who's going to be setting up that database, they can log in, they have some sort of permissions, and then maybe you have a data engineer who's creating transformations if you even want to do that. And they can all kind of work together. The data modeling aspect of it is, we provide tools for that. You can use different languages to create transformations. Right now we support SQL and TypeScript. We hope to support Python relatively soon as well. So, you're able to work with the kind of tools that you're kind of expecting to do that, and then push it into systems that you care about. So really, that's the high level answer. Johnny, what do you have to add to that?
Yeah, no, we're targeting a glide path where you can kind of come in and just purely through UI capture data from a system you care about and move it into another system that you care about. I mentioned that collections have JSON schema. You can very much get into writing your own JSON schemas to ensure that that your collections of data are pristine, or you can ignore that aspect because our connectors generally write that schema for you, and you just use it. So it's a bit of a choose your own adventure type answer where you can get value from just connecting to data, systems that are not currently connected. And as you pull back the layers, I mean, obviously we're operating in kind of a space where there are sort of deep architectural considerations that an organization might want to make around how they're moving data throughout their entire platform. Of course, we would love it for people to be using Flow for more of that stuff, but we very much encourage and support sort of picking a single use case, starting there, seeing how it works for you, and then take it step by step. One other angle I'll throw in here is just there's really kind of a hybrid workflow where it's both UI and also GitOps. So you're able to sort of take a work in progress that you are for a transformation you're building, for example, and then take that to a Git repo and manage it there and share it with your team through that Git repo, and you can go back and forth.
Yeah, the deployment management was going to be my next question as far as how do you go from, testing into production and managing that propagation and versioning of the transformations and data flows that you want to incorporate?
Yeah, you can either sort of do it strictly through the UI. If that's not something that you want to take on, you just want to make a change in the UI and ship it and call it good. That's entirely something you can do. You can also manage this in a Git repo. One other capability of the platform is writing tests. This is actually something that's really hard to do for most transformations. If you're working with DBT, for example, testing is actually pretty challenging to do. One capability that Flow gives you is an ability to sort of write contract tests where you're essentially saying, like, if I have some data that gets written to this collection up here, this sort of upstream collection up here, that's going through potentially multiple rounds of transformation, I expect to see this output in this collection over here, and you can write tests about that, and Flow will verify them before pushing out any changes that might impact that data flow. So it essentially has CI kind of built into the platform where if you're making changes, you can test it locally, and then we will also test it before we set it live just to make sure that you're not breaking a data flow inadvertently.
And then for the case where you are dealing with a source system that doesn't understand incremental flows or push-based flows, so CDC, but I'm thinking in terms of API sources, so being able to pull from a HubSpot API or the Salesforce API, for instance, being able to map between that very required batch-oriented flow into the streaming system. In particular, I'm curious if you have seen any movement in these different SaaS systems toward a more push-based or pull-friendly API design versus we only offer a batch bulk extract interface and that's all there's ever going to be.
Absolutely. To name one, Salesforce, which you just mentioned, we have a real-time connector for Salesforce that is entirely end-to-end streaming. HubSpot as well has incremental updates. So for a lot of these SaaS APIs, it is a polling-based approach, but it's polling to fetch sort of changed data since the last polling interval. And different people have different views on this, but depending on where you set your polling interval, it starts to look a lot like a real-time stream. Hand waving a little bit around the definition of real time. So for these APIs, essentially, in some respects, they are pulled. Some APIs, you're just doing a full refresh every time. And then others are truly streaming.
And so in terms of your experience of building Estuary, working with your customers, seeing some of the ways that streaming data is being integrated into different platforms and data flows, what are the most interesting or innovative or unexpected ways that you've seen your technology used?
One I would say is something I was not expecting. We have an HTTP file connector, which allows for just sort of fetching arbitrary HTTP URLs. And something that has been a little surprising to me, though obvious in retrospect, is how many users essentially just use that connector to grab from a slew of different bespoke REST APIs. So that's proven to be a pretty easy way for people to sort of integrate SaaS systems or APIs that we don't have first-party, first-class connectors for into the platform. Another is we have a Google Sheets materialization, which is keeping a Google Sheet up to date in real time. And that was originally built as kind of a cute toy example of like what Flow is capable of, that it could maintain a materialized view over like a fire hose of data and just kind of reduce it and keep it up to date into a Google Sheet. But, I built it for a demo, and yet users are using it in production quite a bit.
Yeah, that's probably the first thing that they do. They try the Google Sheets connector and just like see a view of their data and make sure stuff is working. Yeah, I think that's right. Like one thing that we learned was just it's really important to have a toy use case available, a toy that you can play with, and just kind of, obviously in hindsight, in retrospect, it makes a ton of sense. No one's going to go and hook up their production database to some SaaS system that they just found on the internet. Right, like they want to try it out and do stuff like that with it. So definitely something we see.
And I was just thinking of another question that I'm interested in understanding a bit more about is for those CDC use cases, particularly for transactional databases. So being able to pull those write-ahead logs from a Postgres or a MySQL. One of the challenges that I've often heard related is being able to reconstitute those very minute details into something meaningful at the other end, where particularly for the case if you have a transaction in the database that ultimately ends up failing and getting rolled back, how do you ensure that you capture that in the end result, and being able to turn these very minute details into a representation that you can actually run analysis on without having to spend a lot of engineering effort dealing with some of these edge cases. And I'm wondering if there are just any off-the-shelf libraries or built-in capabilities into Estuary or some of these other warehouses that help with that translation from those low-level details into a working set of data.
Sure. So two parts to this. One is that databases are pretty good about only exposing committed transactions in the write-ahead log that that our connectors are reading, or generally that you're reading through logical replication. Another aspect of this is time. If you have a capture of a database where you've got multiple tables that are being captured, and those are landing into multiple different collections of data, if you have a transformation or a materialization that is reading from multiples of those different collections of data, you really want sort of the progress of that materialization or that transformation to be in wall clock time order based on the time at which rows were added to those various collections, so that you're seeing the effect. You don't want a customer order to show up before the product record does that you would join against it. So one particular answer to your question is that when reading data, we are doing sort of a live streaming shuffle of data from these different collections. And while there are knobs to control this, generally we're always reading in time order. So you're seeing or transforming or materializing documents in the wall time order at which they were originally written, irregardless of which particular collection of data they're in.
And to add to that a little bit, so the way that we kind of mentioned that the system has an underlying data lake. And the way that underlying data lake actually works is it's an immutable log. So it has every single event, the deletions, the updates, everything. And then we put the burden of actually constructing that into something that a human can read onto a materialization. So materialization can then take those events that are a lot more aggregated and low level detailed and kind of reconstruct the view of the world on it.
Probably getting a little too deep in the weeds here, but another interesting use case is for people who are very heavily invested in microservices, where maybe you're streaming information from multiple different data stores that in aggregate will give you the information that you want, but in isolation aren't terribly meaningful. So maybe you have an e-commerce service that captures the payment info, and then you have a shipping service that will capture the bill of lading. and you actually want to make those two data flows dependent on each other in the end system. And I'm curious if there's any capability to be able to note that dependency between those different data flows within Estuary to ensure that they are materialized in conjunction at the output.
Yeah, when you build a materialization within Flow, a materialization is not one-to-one with a single source of data. A materialization is actually multiple sources of data, multiple collections, which are being materialized together by a single task into a destination. So a materialization connector within Flow is not one-to-one with a source of data to a single materialization. The materialization connector is actually taking multiple sources of data that it's been configured with and keeping them up to date collectively in an endpoint system. So if you have multiple sources of data where you might have these different microservices that you're referring to, and you're materializing them together, then the guarantee that's made is that all of those tables are updating in the overall wall time order at which those events happened. So that's a big part of the answer here.
And in your experience of building Estuary and exploring this streaming integration space, what are the most interesting or unexpected or challenging lessons that you've learned in the process?
So as mentioned, CDC has been a pretty tough nut to crack. That's been a place where we've had to invest a lot of effort in order to achieve really good outcomes for very large databases. In this space, a lot of people just kind of build on top of the Visium and call it good. And we really tried to do that. I promise we tried. And we're kind of dragged kicking and streaming into building our own solution here just to make sure that very large databases have a good experience of doing backfill. It's not acceptable to fill up the database disk. So other aspects of this are that building a pull-based capture is fairly, I'm not going to call it easy, but it's a simple conceptual model that you've got a connector that's sort of reaching out into a system and pulling data from it. But there's a really key capability that also comes up, and you mentioned it a little bit earlier around microservices, where you really want to be able to push data into a capture as well. If you've got like a serverless function, for example, that's interacting with a user through an API that you're providing, and then it has some events that it's produced through its action, and you want to put those events somewhere, what's the simplest thing you can do to do that? And I would say that it's probably just like calling a webhook, doing an HTTP post to basically dump that event data somewhere. And being able to, we offer an HTTP ingest connector that is push-based in nature, and making that work was actually quite interesting and got us into this whole like connector networking epic of work.
I would add that we all talk a lot about data quality, but a lot of the times what data teams really want is they want their data to keep flowing. And so something that we definitely learned is that you really need to prioritize that and at least provide the tools to make sure that even if schema's changing or something like that out from under you, there's a way to ensure that that goes downstream, and a way to like bypass standard data quality checks that you might want to impose around schemas and stuff. So automation of schema drift and going and making its way downstream into a database, new tables coming downstream, all those things are really, really important, and potentially more important to a lot of data teams than quality is, for instance.
And expanding on that slightly, there is not a single schema for a collection of data. There's actually really, you want a write time schema and a read time schema potentially, because that write time schema, if you've got a source of data that's not under your control, you kind of want to accept those writes no matter what. And you still might want very strong schema validation, but if you do it at read time, you can ensure that you're not losing any data. And if your pipeline breaks because the read time schema is wrong, you have an opportunity to fix it without losing any data along the way.
For people who are building their data systems either from whole cloth or evolving from an existing state, what are the cases where Estuary is the wrong choice?
I would say a lot of the people that I talk to here that we have SQL transforms and they think we can be their analytics systems, which is not what we're intended to be, right? We're not an analytics system. We are a data pipelining platform. So we're used to create long-lived transformations that feed into other systems and populate those. And then a batch system is much better suited to ask point-in-time questions, to answer point-in-time questions, versus a streaming system most of the time, right? If you're doing exploratory data analysis, you probably want a batch system versus a streaming system. And the advantage of using a streaming system in conjunction is that you can have a real-time answer, right? Like you can have all of your data, including what's happened very recently. So I'd say that that's like one of the things that we see often.
Yeah, we're great at operationalizing the answers to questions that you've already learned how to ask. For questions that you're still figuring out the question, just an easy ad hoc query capability is probably most suited for what you're after.
And as you continue to build and evolve the Estuary platform, what are some of the things you have planned for the near to medium term, or any projections that you have about the streaming ecosystem as we move forward?
Yeah, I think the biggest is transformation, and I don't think there's a single right answer here. SQL is obviously great in many cases for writing transformations, and we've invested in it for that reason. However, we also see plenty of people use TypeScript. Python is extremely popular, and I think there's a whole new class of streaming transformations and just transformations in general, which I'll call like AI pipelines, and just grounding it out specifically, like prompt engineering. If you want to integrate ChatGPT into a operational pipeline where you're asking it to do something over kind of different contexts, you've got to call out to OpenAI in order to do that. And you can't do that with SQL. So this, capabilities of transformation where you might be integrating vendors and third-party services that are helping you in that transformation is another ingredient here as well. So something I'm excited about is just being able to deliver like a rich, canvas of options for doing transformation within these streaming pipelines.
Are there any other aspects of the work that you're doing at Estuary or the overall space of streaming data integration that we didn't discuss yet that you'd like to cover before we close out the show?
I feel like you've done a pretty good job of nailing a lot of the questions that we could have possibly thought of. So yeah, thanks for having us.
All right. Well, for anybody who wants to get in touch with each of you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get each of your perspectives on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I would say we've spent a lot of time talking about sort of some of the details of batching and streaming data and how we're transforming data and that sort of thing. I think the larger work still to be done is democratizing this within organizations and allowing more stakeholders with differing capabilities and differing technical capabilities to access and leverage the data that exists within an organization. We've spent quite a while as an industry where we've had these like data teams that are this narrow roadblock and bottleneck for the needs of their organization. And where we really need to move to, and the modern data stack has helped here some, where we really need to move to is enabling much larger cohorts of personas within an organization to effectively work with and understand and discover the data that's available within their org and understand how it was built and why.
I would probably say that's a very good one. I'd add that a lot of the tools that we've seen come out in the last few years have been very purpose-built for a specific single problem, right? Like you have get data in its exact format from one place to another. And I think those are probably not the way that we're going to be working with tools in the future, right? We're going to be looking at more platform type approaches, tools that allow you to do more of the holistic data engineering story within a single place. One of the problems that I think we see and that we have all these point solutions is that they encourage people to not talk to each other, right? Like people do their own little thing. You have software engineers that are producing data engineers that are consuming data, and this big gulf that happens maybe between them. It'd be really nice if they were more collaborative and we could bring the two together so that, we had just a much easier way to, when we're advancing data sets, we had a much easier way to make sure that that's going to work, to filter it downstream, to know how it's going to affect all of our analytics that are highly dependent on that.
Yeah, absolutely. The get rid of the situation of, hey, I added a new column to the database, or hey, I dropped this column or changed the type, and now everything else downstream is broken. Surprise!
Yep, exactly.
Absolutely. Well, thank you both very much for taking the time today to join me and share the work that you're doing at Estuary. It's definitely a very interesting product and platform. It's great to see folks investing in making streaming data a more viable option for a wider range of industries and people and organizations. So appreciate all the time and energy that you're putting into that. And I hope you enjoy the rest of your day.
Thanks for having us, Tobias. Good to meet you.
Yep. Thanks for having us. Cheers.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.